Okay. So to find the derivative of a function, we're going to learn a shortcut rule. But before we do it, we're going to do it the long way. So I have this long polynomial that has lots of different terms, and this is going to be called the power rule shortcut that we're about to learn. So first, we're going to rewrite the limit definition of the derivative, which is, let me change, make it bright color here. The limit as h goes to 0 of f of x plus h minus f of x all over h. Then f of x plus h is replacing all of these with x plus h's, right? So I'm going to have x plus h to the fourth minus x plus h to the third plus 2 times x plus h to the second and 3 times x plus h plus 100. So I'll kind of do this, try my best to color coordinate this. So f of x plus h is going to look as follows. X plus h to the fourth minus x plus h to the third plus 2 parentheses x plus h squared plus 3 parentheses x plus h plus 100. So that's f of x plus h. Minus f of x, well, that's x to the fourth x minus x cubed plus 2x squared plus 3x. So that's just rewriting the function. And again, all over h. So at this point, this is going to be kind of annoying. I'm going to have to essentially multiply out all these parentheses. And the long way would to literally be write out x plus h times x plus h times x plus h times x plus h and multiply those all together. So I'm just going to do a quick review of something that I know I've shown you guys in the past, which is Pascal's triangle. And I can actually use this to determine how these will multiply out. I'm going to say at this point, just trust me on this. It works. So just we'll go with it. So when I do x plus h to the fourth, I'm actually utilizing this line. That's going to be all the coefficients when I multiply out x plus h by itself 4 times. So I'm going to have 1x to the fourth plus 4x to the third h plus 6x squared h squared plus 4x to the first h cubed plus 1h to the fourth. So that's this thing expanded out. Minus, all right, so when I'm doing x plus h cubed, I'm using that line. So the coefficients are 1, 3, 3, 1. So we're looking at 1x cubed 3x squared h plus 3xh squared plus 1h cubed. Then, so that's this guy expanded out. 2 times x plus h squared, so I'm going to distribute the 2 at the end. When I do x plus h squared, I can utilize this line, the 1, 2, 1 line. So we're looking at 1x squared plus 2xh plus h squared. Plus, I'm actually just going to go ahead and distribute because that's simple, 3x plus h. 3h, I mean. Plus 100. So that is the expanded form, still with a few things I need to distribute, but expanded form of f of x plus h minus f of x, right? So I'm also going to distribute the negative with the red ones here. So we're looking at minus x to the fourth plus x cubed minus 2x squared minus 3x minus 100. This giant expression all over h. And again, still the limit as h goes to 0. So you can understand that mathematicians wanted to find a shortcut because this is just a pain. All right, so let's see what happens. X to the fourth, negative x to the fourth. Those cancel. When I distribute this negative here, I'm going to have a negative x cubed and a positive x cubed. Those are going to cancel. When I distribute the 2 into the parentheses, I'm going to have a positive 2x squared and a negative 2x squared that cancel. And a negative 3x and a positive 3x that cancel. So everything that I'm highlighting here in yellow is going to cancel. And what the benefit of that is, now every single term is going to have an h on it. So if I do the limit as h goes to 0 now I have 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the fourth. All right, I'm distributing some negatives now. So the highlighted term is now gone, but I have minus 3x squared h plus 3x h squared plus, sorry, these should be minus signs, minus h cubed. I'm going to distribute the 2 into the parentheses. The highlighted term should go away, though, the x squared, the 2x squared. So we have plus 4x h plus 2h squared. That 3x is gone, but I still have a 3h. And that's it, all over h, right? All the highlighted terms are gone because they had a counterpart that could cancel. All right, so now what happens is every term in the numerator has an h in it. So I could cancel out an h in every single term. So now this h is gone. This is now an h to the first. This is an h to the second. This is an h to the third. This is an, that h is gone. This is now an h to the first. This is now an h to the second. That h is gone. This is now an h to the first. And that h is gone. So let me rewrite it so you can see exactly what's happening here. We have the limit as h goes to 0 of 4x cubed plus 6x squared h to the first plus 4x h squared plus h cubed minus 3x squared minus 3x h to the first minus h squared plus 4x plus 2h plus 3. No more h in the denominator. So now when I plug in 0 for h, I'm not getting indeterminate form. What's going to happen is if I do plug in 0 for h, this term gets wiped out because it's 6x squared times 0. This term gets wiped out because it's 4x times 0. That term is gone because I'm plugging in 0 for h. This term will be gone because I'm plugging in 0 for h. This term is gone. This term is gone. And so all I'm left with after I plug in 0 for h is 4x cubed minus 3x squared plus 4x plus 3. This is f prime of x. So I'm going to analyze this. Let me slide this down, or no, maybe I'll just write it underneath. The original function was given as x to the fourth minus x to the third plus 2x squared plus 3x plus 100.
Oh my God. Oh God, that's so. Is the shortcut basically the derivative is Okay, so for example, like it's 4x to the third, so you just put the 4 to the x to the third, and then you put the 3 next to the x to x squared, and you put the 2 next to the x, and then you just put 3 by itself, right?
Yep. So this is notation for derivative. D dx is another notation for derivative of just an expression. So the exponent is going to swing in front, and then you decrease the exponent by 1. So the derivative of x to the fourth, the 4 goes in front, and if I decrease the exponent, then it becomes 4x cubed. The 3 is the exponent, swings in front, becomes 3x, and now I decrease the exponent by 1, and I get 3x squared. The 2 multiplies with the coefficient that's already in front, and it becomes 4, and then if I decrease the exponent, it becomes 4x to the first. The 3x to the first, when I decrease that exponent by 1, I get x to the 0, right? I don't actually have to write x to the 0 here. And then the constant just goes away, because if I think about a constant by itself, what's the slope of y equals 100? If I just graph the line
0.
y equals 100, the slope will be 0, right? So then that just, the derivative of that is 0. So I mean, I guess I could write plus 0 at the end. So the power rule is that if I take the derivative of x to the any power, it's going to equal n times x to the n minus 1.
That's so cool.